Number 9. Very short little question, 4 marks, write down the 1 mark for writing down the derivative of tan x. That's very handy. So the derivative of tan x is simply sec squared x. That was 1 mark in a fraction of a second. Next part, show that 1 plus tan squared x is sec squared x. Well, there's 2 ways you could do that. You could do it starting with that as an identity, using the usual format of left-hand side and then showing its mix to the right-hand side. The obvious thing would be to split that into sine squared over cos squared, then combine them into a single fraction, since there's only 1 part over here, so that'd have to be a cos squared plus a sine squared, and cos squared plus sine squared makes 1. And 1 over cos squared, by definition, is sec squared, which equals the right-hand side. You could do that, which is quite lengthy. Or you could just start from that equation, which is sine squared plus cos squared equals 1, sine squared plus cos squared equals 1, and then just divide everything by cos squared. So you've got sine squared over cos squared plus cos squared over cos squared equals 1 over cos squared. And then you've got tan squared plus 1 equals sec squared. That's usually what you would do just to remind yourself of that if you're going to use it in a question somewhere. So either of those ways would do. Which means the last part of it, what's the integral of tan squared of x dx? Because you can't just integrate that directly, because that's a function of a non-linear function there, and there's no related derivatives. So for that one then, I would simply use this relationship here. I would say, well, tan squared plus 1 is sec squared, whichever form, so tan squared must be sec squared minus 1. So that must be sec squared minus 1 dx. And you already had, if the derivative of tan is sec squared, then the integral of sec squared is tan. So that just must come to tan x and x, and don't forget plus c, and there you are.